once you have authenticated a user, we need to ensure that that user's information is private. Now, that's not a difficult thing on a wired network where people would actually have to tap into the wire to get the signal. But we're talking about a wireless network. And a wireless network sends those radio waves any which way. So anyone with an antenna sitting out can capture those wireless waves and that communication to that wireless access point. Remember, that wireless access point is receiving information from all directions. When we send from our laptops or our smartphones or anything, information over a wireless network, that is not beamformed directly to our wireless access point. That is emitted in a very wide circle in an attempt to get to the wireless access point. So that information is in the air. So we need some type of encryption process that allows us to protect our information. Now, there's many ways to do this. We use a cipher oftentimes in order to hide our plain text. So let's say Susan is sending a message out there, and its computers were invented as a natural progression from a calculating mathematical machine. That's her message. She's sending that in plain text. But we don't want Bill, who is also in the area, to capture that information and be able to read what Susan is saying over the wireless network. So we need some way to hide or change the information so that Bill cannot understand what's being sent, even if he does capture that information. So what we're going to use is a cipher or an encryption process in order to do this. A great example of this and what you see on the screen is a letter shift. We're going to change an A to a D and then a D to a 5 or a B to an I. This is a very simple type of encryption. We don't much use this anymore because they're very easily cracked. But just for an example, we're going to use it here. And that plain text message that we send gets changed and modified. And when it's sent in the air, what's actually being sent is AGT 5RE parentheses 6H. So it's not readable, is it? Now, our wireless access point, or at the other end, we have a key. And this key has the solution. It can solve that cipher that we put in play. So A is to U, B is to I, C is to 2. So it goes through this process, deciphers it, and then on the other end, that message is now back in plain text. Computers were invented as a natural progression from that. We get the whole message. Now, some of the protocols we use are WEP. This is Wired Equivalency Privacy. This uses a shared key. That means both sides have the same key and it's shared among everybody. This was cracked very early on and no longer used. Then we use TKIP, Temporal Key Integrity Protocol. Now, TKIP can be used in as a suite with many other methods like WEP and WPA. We no longer use this with WEP. Like I said, WEP is done. Don't use it in your environments. Even in a legacy situation, I would look into moving forward there. Do not use WEP. It's very easily broken. Then there's AES, Advanced Encryption Standard. This is used with WPA, which we're going to talk about later. This is something that we see in modern use a lot in modern environments. So several different types we can use here. Like I said, we're moving from a plain text to a cipher. The cipher comes out with the encrypted message. The encrypted message is then received, deciphered, and brought into plain text. This is important because we don't want anyone to be able to read this. Now remember, this is what's being put over the radio waves. This message here is going over the radio waves. So even if someone with an antenna grabs this information, they won't be able to read what's going on. So we're talking about encryption, and we talked about a cipher that actually turns our plain text into ciphertext, something that is very, very hard to read. But let's dive a little bit deeper. There's two main types of processes here. There's the symmetric process and the asymmetric process. Let's talk about the symmetric process first. The symmetric process uses a cipher key that is a mathematical algorithm, or maybe even some other method to encrypt the data, right? We're encrypting the data as we send it out. A symmetric key just reverses the process. So this key here is the exact same process in reverse in order to return that ciphertext into plain text, something we can read and decipher. So that Bill here in the middle cannot capture our information and use it, right? This is the symmetric process. Now there are some issues here with the symmetric process. Let's talk about that. Let's talk about what might be the issue if the same way I encrypt the data is the same way I decrypt the data. Well, I'm using this process twice. It is easier to crack. Why? Because I have two susceptible points. I have the end station and the originator of the message, right? So this is easier to crack. I'm not going to say easy to crack. I should say easier to crack. One of the benefits of this is this can be done on a packet by packet basis. This can be done very easily. The overhead here is small because I'm not running a different algorithm on the other end. It's not as complex. So we gain something, we lose something here, right? We gain ease of use. We can do this on a packet by packet basis because it's fast. But because it's fast and it's easier to do, it's easier to break. So not exactly the best or safest way of encrypting our data, but it's a way, it's useful in some sense. It's very useful for if you want to encrypt video, you know, a stream of some type. You have to use symmetric encryption. Now, asymmetric encryption is a little different. I have a cipher key, and this process is different from my original cipher. The cipher is different from the key used. So it's a different process. This is more complex mathematically. And because it is more complex mathematically, this takes a lot more overhead to do. It takes time for the cipher to encrypt the process because it is much more complicated mathematically. And the key on the other end is much more complex mathematically in order to break down the ciphertext. That means this is not on a packet by packet basis. We cannot do that. The overhead is too high. But because it is complex like that, it's harder to break. But because it's harder to break, it is much slower than our counterpart. Now, I said we might use symmetric encryption when speed is key. Asymmetric credentials or asymmetric ciphers are usually used when speed, it doesn't matter, like user credentials. We're going to make sure that who's on the other end. Oftentimes we'll use credentials. Most often we will use an asymmetric key. It's more secure. Now, like I said, this is most often you might be able to find an asymmetric type of encryption that is not as good as another type of symmetric encryption. By and large, asymmetric is going to be more complex and slower and harder to break. Symmetric is going to be faster and easier to break.